Assalamualaikum and good morning. So for today, we will learn chapter 6, angles and tangents of circle. Okay, welcome to the class. Okay, for today's lesson, make and verify conjectures about relationship between angles at the circumference and central angles subtended by particular arcs. And determine values of angles in circle. Okay, so the first subtopic is angle at the circumference and central angles subtended by an arc. Okay, so we want to do some flashback here. Okay, do you remember this one? Chord. Okay, this is chord. Okay, diameter. Okay, and this is a radius. Okay, and this one is the center of circle. Okay, and outside here is the circumference. Okay, and this one is the major arc. Okay, as you can see here, this one is the major arc, minor arc. Okay, minor sector. Okay, this one is the minor sector. Okay, and the red one here is the major sector. Okay, so for today we want to learn angles at the circumference. For this example is here we want to find what is the value of angle at this Q. Okay, the red one here. Okay, so you can see this is chord, this is a chord also, and this one is the arc PR. Okay, and this one is the other example. Okay, PQRS. Okay, so we move on to the next slide here. Angle at the circumference. Okay, so angles at the circumference subtended by the same arc are equal. Okay, which means that the angle at R, S, and T here are same. Okay, so I want to show you how to get this type of angle. Okay, how to do this one. Okay, so what is meant by the same arc? Okay, so here P, where we move to P, okay, and then you have R here, and then you go down at Q, okay, and then you will go back, okay, at this arc, okay, and then you find P, point P here, okay, and then you see there is two lines here, okay, which mean that you can go through here, this line. Okay, let's say we go to this line here, and then we find S. Okay, and then move down to Q, and then you're going to the same arc again to the P. And then when you go to the P, and then you got another line here, okay, and then you move to this line, through this line here, and then you going to point T. Okay, and then you go down again and you find Q here, and you will go to the same arc also. Okay, so when you do this one, okay, when it goes to the same arc, this angle at the circumference also same. Okay, so R, S, T have the same value. Okay, so this one, as you can see, this shape, we call it as a butterfly shape. Okay, butterfly, as you can see, this one is the butterfly. Okay, maybe we use some other color here. Okay, you can see, okay, this one, Okay, you can see here is the butterfly. Okay, this one we call it as a butterfly shape. Okay, when you see the butterfly shape here, the angle at the circumference are same. Okay, so now we move on to the question. Okay, to the example here, calculate the value of Z. Okay, so this one, we know that this angle here is 35. Okay, as I'm doing this, okay, going down here, going to the same arc, okay, and then you find another line, okay, another chord here, okay, and then you're going down, and then you are going to the same arc again, okay, which means that, okay, Z here, the value of Z here is equals to 35 degree, okay, because the angle here are same. Okay, how about this one? Okay, this one is B. So same goes to B. Okay, you can see the butterfly shape here. Okay, so we start here. Okay, from line here and then going down. Okay, and then you go to the same arc here. Okay, you are going to the same arc here. Okay, then going up here, going down, and again you are going through the same arc. So for this one also, Z is equals to 25 degree. Okay, so this one is the first properties, which is angle at the circumference subtended by the same arc are equal. Okay, so we move on to the next one. Okay, the next one here is angles at the circumference subtended by arcs of the same length are equal. Okay, if the arc length PQ is equals to arc length SU, then PRQ, okay, the angle PRQ is equals to angle STU. Okay, so which mean that, okay, this PQ, okay, let's say this PQ here is 3 cm, okay, and this one is SU is also 3 cm, okay, which means that the angles also same. Let's say the angle at T here is 40 degree. So same goes to this R. Okay, it will become 40 degree because the length, okay, the length of the arc here is same. So same goes to the angle at the circumference. Okay, the second one here, the size of an angle at the circumference subtended by an arc is proportional to the arc length. Okay, so you can see here, okay, this one is if the angle here is 3x, okay, and the length of arc here is 3y, okay, so it is proportional, okay, the angle, the size of angle here is proportional to the arc length, okay, so if this one is only x, so this one will become y only, okay, so this means that by that size of an angle at the circumference is proportional to the arc length, okay, if this one is 3x, so this one will become 3 times, okay, 3 times proportional to the angle, okay. So now we see the example. Okay, based on the diagrams below, calculate the value of x here. Okay, so calculate the value of x here. Okay, so the first one here, you can see that these arc length are same. So we know that this one must be same. Okay, angle at the circumference must be same. So the first one here is x is equals to 40 degree. Okay, so the second one here, okay, we see that this one, okay, this one is the proportional. Okay, so this one is 60 degree. Okay, this one is equals to 8 cm. Okay, so if this length here is 4 cm, how to get x? So x is equals to 60 degree over 2. Okay. Okay, so x here is 30 degree. Okay, so means that is proportional. Okay, proportional. Okay, that's why you divide by 2. Okay, because when 8 divided by 2, you will get 4. Okay, 8 divided by 2, you will get 4. So that's why you divide 60 here with 2. Okay, and the last one here. Okay, as you can see here, this one is the angle. Angle are same, 25. So means that the arc length here also same. So x here is equals to 3.6 cm. Okay, so now we move on to the central angle subtended by an arc. Okay, so we want to see one by one here. Okay, the first one, okay, the size of the angle at the center of a circle, okay, subtended by the same arc is twice the size of angle at the circumference. Okay, so remember, angle at the center here is twice. Okay, twice the size angle at the circumference. This one, circumference. Okay, by the same arc. So I want to show you by the same arc. What is mean by the same arc? So P is going to Q and then going down to R here. Okay, and then it goes to this arc. Okay, and then when you go to the center, okay, and then going down to R, and then it goes back to the same arc here. Okay, so this one is the first one. Okay, the first one. Okay, how about the second one? The second one also the same. Okay, so you must remember center, angle at the center is twice the size angle at the circumference. Okay, this one is circumference. Okay, so now we want to see, okay, here, same arc, is it the same arc here? Okay, P going to Q. Okay, go to R. Okay, going to the same arc here. And then from P here, going to the center. Then going to R. And then it goes back to the same arc. Okay, so you can see this one is the first one. Okay, second one. Okay, and the third one here. Okay, so you can see different type, but still is about angle at the center and angle at the circumference. Okay. Okay, so next one here, also the same angle at the center here is 2 times, okay, which is twice angle at the circumference. Okay, next we check, okay, is it going the same arc? So P going to Q, okay, and then it goes to R, okay, then goes back to P using the same arc here, okay, and then P go to the center, then goes to R, okay, and then goes back to the same arc here, P. Okay, okay, now here the fourth one. Okay, okay, So this type, okay, this one, this is angle at the center, okay. So you must remember the position must be same. Okay, position must be same. So this one is angle at the center, okay. And this one is angle at the circumference. Okay, so this one is it the same arc here? Okay, PQR. Okay, this one is PQR. Okay, this one you just see that this type, okay, you have P, you have Q, and you have R at the circumference, okay. And the center here is O, okay, center of the circle. So you know that, okay, this one, the angle at the center must be twice the size angle at the circumference. Okay, for this one, okay, actually for this one, okay, we call this type is a rocket. Okay, you can see this shape as a rocket shape. Okay, so remember there are 4 different types of this central angle subtended by an arc. Okay, so we see an example here. Okay, determine the value of x and y for each of the following. Okay, so now, okay, I will show you here. Okay, so first you can see a rocket here, a rocket shape here. Okay, going to the same arc here, and then going up, going to the center, then goes down, and then it goes back to the same arc. Okay, so this one, so we know that this angles is twice. Okay, so means that 2 times. Okay, so how to get x here? So x is equals to 80 degree over 2. So x is equals to 40 degree. Okay, now how to get y here? Okay, how to get y here? Okay, this one is the, as we see before, okay, this one is the, you can see this one is the type 3. Okay, type 3 here. Okay, type 3 here. So actually it's also the same. Okay, so this one, okay, you go to the circumference, okay, and then going to the same arc here, then goes back to the center, okay, going to the same arc. Okay, so actually this one also the same. Y is equals to 80 degree over 2, so y is equals to 40 degree. Okay, so now you can see B here. Okay, so B here, okay, this one is type Y. Okay, so you can see Y and 35 here. Okay, if we goes back, okay, so you can see this one is actually is type 2. Okay, type 2 here. Okay, so go to the circumference first. Okay, and then going down. Okay, and then goes to the arc here. Okay, and then go back to the center, goes down, and it goes to the same arc. Okay, so which means that this one is twice. Okay, remember this one is twice. Okay, so y is equals to 35 degree times with 2. So you get here 17. Okay, so how to get x here? Okay, this one you can use the first one that we learned, the butterfly one. Okay, So you can see this one is a butterfly. Okay. So here is X and then goes down. Okay, and then goes to the same arc and then you goes back up here. Okay, and then you go down and it goes to the same arc. Okay, so here you can see these angles are same because at the circumference. So here will be X is equals to 35 degree. Okay. Okay, so we move on to the next example here. Okay, the diagram on the right shows a circle with center O. Given that the length of arc PQ, okay, is equals to QR. Okay, the length here are same. Okay, and major angle POQ is equals to 310 degree. Okay, so POQ is here. Okay, POQ. Okay, calculate the value of X, Y, and Z. Okay, so the first one here, you need to find X. So X here, okay, what you can do is, we know that this one is 310 degree. Okay, so you want to find X. So we know that one whole turn here is 360. Okay, so first question here is A. So X is equals to 360 degree, okay, minus 310, okay, so X here is equals to 50 degree, okay. Okay, now we want to find what is Y. So B here, okay, so Y, can see here, okay, so this one, as you can see, this is a, okay, this is the radius, okay, so this one also radius, okay, and this Y will be, okay, is a triangle, which is isosceles triangle. Okay, isosceles triangle. Okay, so we already know X here is 50. X here is 50 degree. Okay, so can you find Y? Okay, so 180 minus by 50. Okay, you will get this one is 130. Okay, 130 degree. So Y here is equals to 130 degree divided by 2. So Y here is 65 degree. Okay. Okay, now we want to find Z. So how to get Z? Okay, this one is, you can see the shape of rocket here. Okay, you can see here shape of rocket. Okay, goes up here. Oh, sorry. Goes to this arc and goes back to the same arc. Okay, so this one is rocket. So we know that angle at the center here is twice, okay, twice the size angle at the circumference. So Z here, okay, Z means that here until here. Okay, Z, which is here is Z, total here, Z, okay. So for this small angle here, okay, so we know that this one is 50. So this one is twice. Okay, so 50 divided by 2. So you will get 25 degree. So the small angle here is 25 degree. So you want Z. So Z is equals to 25 times 2. Okay, why I'm times 2? Because, okay, this one, this angle here, okay, this the length of arc here are same, PQ and QR. So which means that the angle here also same, have the same value. So 25 times 2, so you will get Z is equals to 50 degree. Okay, so that's all for today. Okay, see you in next class.